Thank you all for joining our webinar this evening entitled Exploring the MethylDetox Profile. This is intended to be a practicum really about understanding questions that no doubt you have been receiving and will receive about methylation and detoxification and the genes involved in that process. I think it's interesting in this time, this post-genomic era, that we're making new discoveries. This cycle of methionine and homocysteine metabolism has been an area of very intensive investigation lately. It's an area that's of great interest to people, healthcare providers and their patients, and so it's a great area to us to service the needs of people to understand their biochemistry more deeply. Many years ago, a physician from Harvard named Kilmer McCulley discovered the association between homocysteine and cardiovascular disease and other degenerative diseases, and hypothesized, it was called the homocysteine hypothesis, and he took a lot of heat for that. In fact, he was basically had to leave Harvard because of that. It interfered tremendously with new drugs coming on the market for treating high cholesterol and so forth. And at the time, it was very simple. He proposed that a mutation in the methyl tetrahydrofolate reductase gene was responsible for elevated homocysteine, which was pathogenic. And the treatment for that was to supplement with vitamin B6, folate, and B12. It was very simplistic, and I know over the many decades, I read that book decades ago, and in that time, I've been to many meetings where homocysteine's been discussed, and there's been a back and forth as to whether or not homocysteine levels are that meaningful. And it was confusing. People weren't really sure. There was conflicting information. And now I've met Dr. Salita and understand that there's a great deal more to the process than just that one gene. There are many genes involved, and there are many steps involved in these pathways. And that's what he'll be speaking with us about this evening. We're also joined by Jim Hoover, who's our sales director at Cell Science Systems, and he'll be able to speak about the implementation or the logistics of utilizing the test in your practice. We were going to be joined by a couple of other panel members. They unfortunately couldn't make it, and they send their regrets. But I think anyway, we have a full program tonight, and I want to turn this over to Dr. Salita.
Actually it's Chilida, but Chilida, yeah.
And he has a lot to tell us tonight. So.
Well, thank you very much, Roger, Mr. Deutsch.
It's actually Roger.
Yeah, it's.
You can still call me Jim.
Oh yeah, thank you, Jim. Okay, so and yes, what we want to talk today is about about a homocysteine methionine pathway. I'm going to skip everything, kind of who we are. Mr. Deutsch said already everything. So far, what we're going to show in this seminar, the objectives are actually what we are talking about: homocysteine methionine, MTHFR, identify the most important genes involved in the methionine homocysteine cycle. And that's what Mr. Deutsch said. There is more to that than only MTHFR. And so far, we're going to look at this different mutations in the different genes which control this methionine homocysteine cycle. We choose to call it methionine homocysteine cycle. We're going to show you later on why. Then we're going to see also how these mutations impact the homocysteine levels. But you see, genetic testing only says you something, kind of what is wrong. But, and this is the new thing, genetic testing was done in the past, only revealing the SNPs you have. But it should also be done something about those SNPs, because you can't actually cure your DNA. You can go over that and give in a lot of cases, personalized intervention according to the genetic result, what can be targeted nutrition, going to come to that later, also targeted supplementation so far. And what is very important, when you provide this targeted nutrition or targeted supplementation or even targeted treatment, kind of you can monitor, or you should monitor the progress of your treatment by using different markers from the blood. And here we recommend to use homocysteine levels in the blood. There are more markers to that, but we're going to come to that later on. Okay, so yeah. This is the whole thing. This is the homocysteine cycle and kind of how it affects other metabolic pathways. The homocysteine cycle or homocysteine methionine cycle doesn't stay alone. It is involved in methylation, that's actually the major part of it, but also it is involved in glutathione synthesis, and this is a very important part.
Is it reasonable to say that glutathione is perhaps the most important of the three enzymatic antioxidant enzymes in the system?
It's very important because it's actually the phase 2 detoxification, what is a conjugation reaction, what we say, and glutathione plays here the most important part. Also very important, what we did a lot in Germany, metal detoxification of metals.
Bottled water. Bottled water.
Yeah, bottled water. Kind
Mercury.
of the Romans died, or the Romans had problems because they had too much lead in their water. So no, glutathione, especially the enzyme glutathione transferase M1, but also T1, which has a deletion in the population. A lot of people don't have this enzyme. Genetically, it plays a very important role in detoxification.
I know you're going to. I don't want to jump ahead.
Yeah.
When you use the term deletion, I know you'll have to explain what do we mean by
the gene is not there.
Okay.
The gene is not deletion. It's a special kind of a SNP, which says
not there, or
the gene is not there.
Okay.
Yeah.
Or is it a nucleotide that's not there? Okay, I'll let you.
But you see, this is glutathione synthesis. Kind of the whole methylation pathway has also an impact on mitochondria, also in connection with the glutathione. And what we said in detoxification. So what we also postulate, kind of, you see on my talk, I'm not from the States, I'm from Germany, but what we postulated in Germany is always you have to look everything as a whole, and not only at one or two specific genes. So this is actually what I wanted to say with this chart. Kind of like, let us go shortly and define what actually a SNP or a mutation is, or a genetic polymorphism. It's very easy. The DNA, our DNA is made out of 4 bricks, or 4 what we call nucleotides. There's thymidine, adenine, cytosine, and guanosine. A special sequence of those 4 nucleotides creates a specific gene. So for example, TACT stands, let's say, for MTHFR, which is normal. But then this is a SNP, single nucleotide polymorphism, when this C is replaced by an A. Okay?
Yeah.
Like here.
So these are like zeros and one in binary code in computer, except
that's
much
exactly
more complex.
So
a combination of all those 4 nucleotides makes up the whole.
Yeah, you would laugh about it, but I studied at the University of Heidelberg, and we were actually looking at that as a binary code.
Yeah.
I actually did my PhD at the Human Genetics Department, specialized in applied physics so far. Okay. But you see, this is kind of what we have here. 94% of the population have here guanosine, which is the normal wild type, and 6% of the population have this guanosine replaced by thymidine. This is a single nucleotide polymorphism. But now, what is the deal about it? It's very easy. Each gene codes for an enzyme, and here we have kind of a red blood cell, and a blood cell which is affected by sickle cell anemia, and this is the case in sickle cell anemia. We have a SNP, and this is the oldest example of a SNP. The fact is the following: here you have a beautiful round-shaped red blood cell, and here you have a sickle cell-shaped blood cell, and this sickle shape comes only through that there is a SNP.
One gene.
In one gene.
One gene is responsible for
one gene, and one SNP in this gene is responsible for that.
It's not always the case that one gene a disease is related to one gene.
Exactly.
It can be many genes, but this is an example.
This is an example, and I would say, Roger, it is one of the very few examples where one SNP affects something like that.
Right.
Yeah. So normally it's a cascade of genes and SNPs in those genes.
Yes. Everybody understands. This is a very easy one for everyone to comprehend.
Very
right?
easy, and kind of what does it do? Sickle cell anemia, it bounds less oxygen to the red blood cells, and it's the same kind of also in the MTHFR gene. When we have there a SNP, the production, or let's say, it doesn't function properly. It doesn't function to 100%. Let's make it in this way.
It confers some protection against malaria, which is
well, that's how sickle. When we talk about it, that's how sickle cell anemia got actually manifested in certain regions, because it's a protection against malaria.
Really?
Okay. Yeah. That's what it is. Okay. A little bit more to how to interpret the genetic results. What we said again. Homozygous positive, this is for the SNPs. When you have a homozygous positive SNP, you have from both of your parents inherited this SNP. This means you inherit actually 2 DNAs from your parents, one from father, one from mother. And when in both DNAs from father and mother is a SNP, we talk about homozygous positive. It's in genetic kind of like has the abbreviation minus, but this is, this is Gregor Mendel. And then heterozygous, it's again the following thing, one DNA from one of your parents has a SNP, the other one is normal. Here we talk about that 50% of the DNA has a wild type and 50% has not the normal wild type.
Now,
yes.
Clinically, that means that the enzyme's there, the genes encode for the enzyme, but there's a bit of a compromise because one parent contributes a gene that has a single nucleotide polymorphism, a SNP, or a mutation, and the result will be the enzyme that performs a function in a particular step in the homocysteine methionine cycle is compromised. It's not unfunctional, but it's just not functional optimally.
It's not functional optimally. Let's say in this case, to give you a hint, in this case you can say, okay, it's functional in between 80 and 90%.
Okay.
Something like
but it still needs to be addressed in some manner.
It still needs to be addressed. Well, this is kind of you have always exception from the rule. In some cases, it's only working to 60%.
Okay, but there's a way to monitor that. We'll get into that.
But we also kind of we are looking for relevant SNPs here, and we also then say in the lab report, what to do. Okay. Now comes the green, homozygous negative. Again, it's plus. Both alleles, this means from both parents, from father and mother, have no SNP regarding this mutation site. So the enzyme regarding this mutation site is 100% normal. Okay. So this is how we come, also we put these colors on. Red, homozygous positive, yellow, kind of watch it, heterozygous, plus minus, green, everything is fine. Okay. Again, what are we trying to do with our functional genetics? And this is very important, and this is actually how functional genetics we understand and how we also applied it for a couple of years back in Germany. This was test the individual's current status. And how can you test an individual current status, a personalized status? Only through SNPs. And then also test the corresponding metabolic markers in blood. This gives you kind of an example, why is it out of shape? Okay. Second, target. According to those results, you can do a targeted, personalized intervention with supplementations according to the individual results of SNPs, and also with corresponding markers of blood. And why do you need these corresponding markers of blood, like in this case homocysteine? Just to monitor progress. Because in the past it was always said, take this pill or take folic acid, then it's going to be better. Yeah, sure, but when this person has a SNP somewhere else, it's not going to be better. So you really, what we recommended always, monitor your treatment, monitor the progress of your treatment, and even kind of so that you can also see when something is going out of hand, you can see it.
Right.
Like here in the homocysteine levels.
In this case, we're talking about monitoring serum levels of homocysteine.
Yes.
It shouldn't obviously be too high. Also, it should not be
too low. Yeah, well, too low is also, but we can come later to that. Kind of like we always say, kind of take the gold, or aristocrats said that, take the golden middle. So far, so far. Too much is not good, too low is not good too.
Right.
Yeah. Okay. So right now the genes what we are looking at right now here is, to give you a short description of that, is MTHFR. Everyone knows MTHFR, methylene tetrahydrofolate reductase. We are looking at the common SNPs, very well known, C677 and 1298. So everyone knows that. The next gene is not so very well known, but it's, to my belief, very important, is the so-called methionine synthase. And what does it say? It actually synthesizes methionine from homocysteine by using vitamin B12. We're going to come later on the chart where we can show you everything, how the pathway goes.
This is MTR, right?
This is MTR. Then we have the MTRR, 5-methyl tetrahydrofolate homocysteine methyltransferase reductase. These two genes work together. So, oh, I see.
That's pretty good. You can say that.
Yeah. I was practicing in front of the mirror. But you see, these genes work together. We call it in science in a so-called ping-pong reaction.
Okay.
And we're gonna later come to that. And then you have COMT, okay, we know all COMT, catachilyl O-methyltransferase. Here we are also looking at the most important mutation sites, the VAL108, 158, a MET mutation site, and ALA 52, 102 tyrosine.
Now those are shorthand for certain amino acids.
Yeah.
Okay.
Because you see exactly what we said. When you 3 nucleotides code for one amino acid, and when one of these nucleotides is replaced, it codes for another amino acid.
Right.
And that's the reason why. And an enzyme consists of amino acids.
Right.
So when the amino acid sequence is not proper, then you get the enzyme out of shape. Okay.
Yeah.
Very good.
And some amino acids are hydrophobic and some are hydrophilic.
Exactly.
So that gives their role in solution. I mean, we're 96% water. So it makes the peptides either go towards the water or away from the water and gives the enzyme its conformation.
Let's make it in this way. It can develop the proper hydrogen bonds.
Yeah.
Okay.
Hydrogen connection bonds, so far. That's what it is. And van der Waals, blah, blah. This is biochemistry, my God. This is okay.
Another time.
The last gene, what we have also in the cycle, it's also a very important gene and not so very well known, is S-adenosine homocysteine hydrolase. And this gene is actually very much involved in methylation. It is important for the so-called methylation potential, what we're going to come later on.
Methylation is important for everything.
Right. It's important, and especially this actually shows you how you can methylate. Yeah. So far. Okay.
So you don't, how prevalent are variances in that AHCY?
HCY, yeah, they are. Let's say it in this way. They are not so much like in the MTHFR, but when they are there, they are very important.
Okay.
So far. Okay.
And I think you're going to get into also like further what conditions these are more prevalent and other conditions associated with it. Okay.
Okay, last but not least, you can monitor right now with homocysteine, which is a very useful marker for monitoring all the genetic SNPs and the targeted supplementation in blood. Okay, back again. That's our whole cycle so far. We are going to look only on this one.
So
the key genes in this.
These are the key genes
which you've just discussed.
Which we just discussed. I mean, there's 1 or 2 more, but there are not so many SNPs in there. But these are actually the key genes which make up the whole homocysteine methionine cycle, what we prefer to call it, or a detox, homocysteine detox, or let's say it in this way, the methylation, potential the methylation. So far. And you see, it's not only one gene, it's a cascade of genes which actually rule the whole cycle. And this whole cycle, what we say homocysteine methionine cycle, has only one task, actually to create homocysteine, like here, and then to create methionine. And methionine and homocysteine only differ in this group, CH3, and that's the so-called methyl group.
Okay.
Can I digress for a second and ask you a question away from the chemistry? Homocysteine levels can increase by virtue of consumption of foods that contain a lot of homocysteine?
Yeah, can also, yeah.
Okay.
But you see, most likely they they increase, but most likely also they increase from improper,
improper metabolism.
Improper metabolism, and you see, this is, I mean, the only thing here, what we say methylation, it only the whole cycle is actually concerning only the CH3.
Right.
That's the whole story behind that.
That's the only difference between the two molecules.
Yes, exactly.
Is the methyl.
Is the methyl.
So methionine becomes a methyl donor.
Methionine is the methyl donor. Homocysteine, actually, when methionine gives this methyl group away, it turns into homocysteine again.
Okay.
And then
So
the
it's
whole
recycling
cycle,
of
that's exactly, that's why we are talking from methionine homocysteine cycle.
So you have a double whammy if something's not working. You might have the accumulation of too much homocysteine, which can be immunogenic and, atherogenic and you compromise then methylation, which is necessary for gene expression and for detoxification.
Yeah, sure.
So that's what we're talking about.
Yeah, that's what we're talking about. And you see, that's the reason why it's so important to look at the whole cycle.
Right.
And not only at one gene. Kind of like we said before, only one gene, the effect of one SNP in one gene, sickle cell anemia, and there's another one in phenylketonuria, PKU,
Right.
And this is actually my doctor father, Professor Vogel in Heidelberg, found that out.
Oh, really?
Yes, that's what I wanted to say. Okay, let us go to this whole cycle. Well, let's go to folic acid here. We all know folic acid. Folic acid goes to two other enzymes which are genetically controlled, but which are not so right now important in our cycle. And folic acid is converted to 5-methylene tetrahydrofolate. And now comes the first player in this whole gene, MTHFR, methyl tetrahydrofolate reductase. The MTHFR is only the task to convert 5-methyl tetrahydrofolate in 5-methyl tetrahydrofolate. Okay? So when you have genetic mutations here, SNPs in this mutation site, what happens? What we said before, your enzyme is not working correctly, not efficiently. So what is the consequence of that? You might have less than 5-methyl tetrahydrofolate here, what you need.
Right.
So what do? We supplement it. It doesn't make much, it makes more sense to supplement 5-methyl tetrahydrofolate in this case when you have SNPs than a supplement folic acid. When you have no SNPs here in the MTHFR, then we can say, okay, supplement folic acid.
And is there a disadvantage of taking a supplement if you don't need it?
Yeah, it can be.
Cyanocobalamin versus methylcobalamin, anything along those lines.
Yeah, well, it can also be kind of this is strict, but there are also new investigations. What I have said that, for example, when you take too much folic acid, it can affect your natural killer cell activity. And this is not so good. Yeah. So kind of like you see, it's always
it's a question of balance.
Yeah, it's with alcohol, with everything. It's a question of balance, you know.
Too much alcohol and you lose your balance.
Yes, exactly. Kind of, and that's what we have to point out. And kind of, I have to mention. Last Friday, a person came to me for consult, and she brought with her literally a bag like this full of supplements, and she goes to me, I'm feeling sick. I go, sure you're feeling sick, look at all the supplements you're taking so far. It's a question of balance, and to bring this balance into order, we look at those SNPs.
Personalize what we're doing.
Personalized. Okay, but let's continue on. You have this 5-methyl tetrahydrofolate, And then comes the methionine synthase and methionine synthase reductase. This methionine synthase takes the methyl group, this methyl group from 5-methyl tetrahydrofolate, attaches it to vitamin B12 and creates methylcobalamin. Mm-hmm. Okay, again you see methyl group, methylated vitamin B12. This group goes to that, and methyl tetrahydrofolate becomes tetrahydrofolate. In a so in the next step, the methyl MTR methionine synthase takes homocysteine, yeah, here, remember, see that, and attaches this methyl group from 5-methyl tetrahydrofolate to homocysteine, creating methionine. See, there's the methyl group again.
So we get our
Now you see, this is a cycle,
right.
And kind of to point that out, MTHFR is only the start of this whole cycle.
Right.
It's only the start. No? So MTRR is also working together with a methionine synthase in a so-called ping-pong reaction, because methionine synthase is doing that constantly creating methionine from homocysteine. Sometimes the methionine synthase gets inactivated, or what we say oxidized.
Okay.
And then the methionine synthase reductase has to reduce it or activate it again. Yeah? So you see, even that nature made 2 genes for that, 2 enzymes, you can see how important this step is.
Right.
Yeah. Okay.
Very interesting.
Yeah.
Now, we don't need to go into the specifics of it, but I'm going to presume there's a lot of information in the scientific literature.
Oh yeah, sure.
About if this SNP is.
Oh yeah, sure.
Okay.
Sure.
So someone
also we're going to come later on also to the so-called COMT inhibitors like quercetin. But we're going to come to that later on.
We have a list of those, yeah.
In scientific literature, quercetin is known since 1990 in the pharmacological literature that it's a COMT inhibitor.
And you helped us put together this, and we have a literature section.
Yeah, sure.
So, okay, that's a good guide.
Sure.
People to be aware of.
I was delighted to help to create that.
No, it's a great piece. Yeah.
Thank you. So, okay, but let's go further on. You see, methionine, see, donates its methyl group to adenosyl, which comes from ATP. Yeah. Okay. As adenosyl 3-phosphate, adenosyl, and creates S-adenosyl methionine. Yeah? This S-adenosyl methionine, together with COMT, then does the methylation. Yeah? So
COMT also plays other roles in terms of metabolism of
COMT
balancing neurotransmitter.
Yeah, COMT stands for catechosyl O-methyltransferase. This means COMT does the so-called O-methylation. But it's very important. You have a lot of methylating enzymes. I have here a list. I can show it so far. You have only in O-methylation, you have 5-hydroxyl-indole O-methylase transferase. You have acetyl serotonin O-methyltransferase. You have beta-in homocysteine methyltransferase. I mean, you have a lot of methyltransferases.
So if someone's listening now and they're interested in really drilling down into the biochemistry, they can contact you.
Yeah, sure.
Okay.
But what I wanted to point out, like I said, we have a lot of methylating enzymes, but very important, all these methylating enzymes are getting its methyl group from semi-E. This means this cycle is universal.
Right.
Yeah. That's the reason why it's so important.
Right.
Yeah. And we're going to also talk about hypomethylation, hypermethylation, or you call it overmethylation, undermethylation. But fact is, this end cycle is very, very important.
And we have lots of people interested in overmethylation. We'll get to that in a little bit. Okay, very good.
Okay, when you have SNPs in COMT, let's say here, then we recommend semi-E because to give COMT more semi-E in order to do the methylation. But this cycle is not over right now. Semi-E, when it's methylating, is becoming, or S-adenosylmethionine, when it's methylating, is becoming S-adenosyl homocysteine. And here we are again at the homocysteine.
Okay.
Yeah? In the next step, and this is the HCY, what we were talking about for, adenosyl homocysteine hydrolase. What is this HCY doing? It's converting S-adenosyl homocysteine back to homocysteine.
Okay.
And the cycle completes and continues from the beginning.
Right.
Very easy, but it's not so easy.
It shows the importance of addressing any genetic dysfunction that you have, have to pinpoint what it is and actually have a therapy designed for that.
But now comes the big thing. Okay, and that's the reason why we are looking at this gene. The ratio between S-adenosylmethionine and S-adenosyl homocysteine makes a so-called methylation potential.
Okay.
Yeah? So,
and why is that?
Very, very important, very important. SME and SAH, let's say it in this way, have to be in a specific ratio. Normally 8 parts of SME, 2 parts of SAH. Yeah? This is the optimal methylation potential according to literature. When you have too much SAH, S-adenosyl homocysteine, this affects your methylation potential. Why? Because the affinity of S-adenosyl homocysteine to, let's say, block methylation is much higher than the affinity of SME to perform methylation.
Well, that could really gum up the whole works because the gene expression depends entirely on methylation.
That's to my belief. To my belief, it's more important to measure the methylation potential than the homocysteine levels. And we're going to have that in the kind of shortly. We are working, our R&D department is working on that we can also offer the methylation potential, because you see now it makes sense, especially when we talk about overmethylation, that you control this SNPs here and control also the methylation potential.
So maintaining that ratio is really what the goal is for realizing
this is very important.
Okay.
And the SNPs have a significant impact on that.
Oh, sure, for sure. This SNPs in the HCY gene has an impact on that.
Okay.
What can also have an impact on that, also very important, let's say it this way, your COMT is good, you have no HCY kind of mutations. And still your methylation potential is up, then you know kind of that you are really needing methylation, that something is going on in the body. You see, you can use the methylation potential also not only to monitor the proper balance, but also to see, okay, what can be going on in the body. Methylation potential is also very, very important, for example, when you are on specific drugs, or when you get L-DOPA. L-DOPA is used specific also in Parkinson's disease. So forth, and then, for example, when the doctor prescribes L-DOPA, they have to use COMT inhibitors like entacapone or tolcapone. So far, very, very important. But we also say in the lab reports, be aware of that. Then don't give SEMI. You see, I mean, it's a very, very important thing so far.
There are some. I know this is a little bit tangential, but I was once visiting with some folks in India. Who were current generation of a long line of people practicing and manufacturing Ayurvedic remedies. And they feel that there actually are some herbs, old Ayurvedic herbs that'll treat Parkinson's.
Sure. They are. I mean, you see, this whole thing is in. I mean, good. I'm from Europe. My grandfather. He studied medicine, and he studied medicine in Vienna, in Austria, and kind of in these times when you studied medicine, you had to study also kind of plants. Kind of, how do you call
botany?
Botany, exactly, botany, in order to know kind of like what is impacting. Yeah, so far. I still have his diploma so far.
Hey, just quick on this then. So homocysteine levels, if they're high or abnormal, or let's say the homocysteine levels are in range then, and you're still possess genetic mutation here, I guess that's one thing to monitor is if someone has a normal homocysteine levels. Are you done? Is your work complete?
No,
You're still addressing
well,
the mutation though where it exists as far as whatever gene is expressing, correct?
When someone has normal homocysteine levels so far, and then you should also, for example, look what we say also at the methylation potential. You look at, at the genes. I mean, when someone has normal homocysteine levels, according to right now to normal standards, he's fine.
Whatever the reference ranges are for the test.
Yes, it's fine. But then again, I would recommend also to look at other things to be on the sure side. And by the way, genetic tests you only have to do once in your lifetime.
Right.
That's about it. The genes, the SNPs are never going to change. Never. But let's also, oh my God, we talk a lot. Let us continue.
That's all good stuff. Yeah.
In this whole thing. And then also to make it very, very clear, homocysteine is not only involved into this whole homocysteine methionine cycle. No, homocysteine is the major template for glutathione synthesis. Yeah.
Right.
This is, and you see, when we are talking about glutathione, we are just right now in the phase 2 detoxification, very important in chelation. We did in Germany a lot of chelation therapies, applied it to metal intoxication so far, and also in glutathione ratio.
Yeah, what I was mentioning before is that we're getting more and more metal contamination.
Yeah, you're getting.
You know, fossil fuels contain metals, and coal would contain a lot of metals, and you know, it's we know it's going into a lot of the water supplies.
Yeah, sure.
And I think the Flint, Michigan case is just the first case, but from what I understand, there's actually thousands of municipal water supplies that are contaminated with metals.
But
so
you see, the fact is also,
and explain a lot.
That's what I did with Dr. Peter Freckleton. I mean, he was owner of King James Medical Hospital in Cleveland. He passed away 2-3 years ago, but we were discussing a lot, and he was right. He actually postulated no metal. There is no metal which is not toxic. Even gold is toxic too. So to a certain degree. Silver is toxic, nickel is toxic, mercury toxic, so far. There's no metal which is not toxic, and that's the reason why we need the glutathione S transferases or the glutathione in order to get rid of that. Yeah.
So what if someone has which gene is the most important? If maybe that's the wrong, they're all important. Is that the answer?
You mean here in our methylation cycle?
Yes.
All of them.
All of them.
I would say all of them.
So you can't take one out of context.
Well, what you can do is the following thing. You can test the most important genes. What I would recommend is MTHFR, MTR, and COMT. Okay? But then when you have normal levels, okay, fine. But then to have a clear picture, I would also recommend to test AHCY and MTRR.
Okay.
But you can make a basic of these 3 genes. Okay, good. Here are the genes again on the side, but I'm going to go to the next picture. Here are the genes with the mutation sites. Here are actually things kind of from blood what you can use to monitor the progress. This is sure homocysteine levels, folic acid levels, 5-methylene tetrahydrofolate, vitamin B12, methionine levels, methylation potential, very, very important, vitamin B6. And here are the targeted supplements, what you can use: folic acid, 5-methylene tetrahydrofolate, methylcobalamin, SAMe-E, an NADH or niacin, and vitamin B6. These are actually the most important supplements involved into that, and according to the SNPs or according to the appearance of the SNPs in what genes, you can do targeted supplementation.
And I guess it's useful for people to know that you've created these recommendations and they're incorporated into the test report.
Thank you for that, but I get my knowledge from biochemistry books.
Right. You've gleaned them from the literature.
Because you see, also kind of like for oxidative stress, everyone says, yeah, take vitamin C. No, for oxidative stress, the most important thing is take manganese. Why manganese? Manganese is a cofactor of superoxide dismutase 2.
Right.
So you see, this is known in biochemistry, but thank you. Yeah, I took the knowledge and put it from biochemistry together. No? Okay. So again, this is the whole cycle. to give you an idea, and we were just looking at this small portion. This cycle, mitochondria, is a totally whole portion. Detoxification by glutathione is a whole portion. But we're going to come in, I hope, in later webinars to that. No. Okay.
Very good.
Good. Last but not least, that finally, we want to represent you here a lab report, what we created. And you see, we also made it in the following way, that we created the lab report in kind of way that you have the whole cycle in front of you.
So it shows you right there if there's no SNP, no variation on those genes.
Yeah.
In this case, COMT is normal, wild type. Homozygous normal. The yellow ones, MTR and MTHFR.
It shows you, Roger, the following thing. Remember what we said, plus, minus, 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 plus, plus? We gave to everything is okay, the color green.
Right.
Here on the first side you have a green color, okay, you see there are no SNPs. Then the second one plus 50-50%, 50% of the enzymes are good, 50% are not, are yellow. MTR, like here, red, 100% of the investigated gene, according to the investigated mutation site in the gene, is not good.
Yeah,
so
the mutation is inherited from both parents.
Exactly. So
that's not good.
Yeah, so you see it on the first glance what is wrong so far.
That might impact the amount of supplementation?
It might impact the amount of supplementation.
That's the whole case.
Identify it first, and then
it gives you, let's say it in this
guidance.
way, it gives you guidance. Because you also have to take into consideration how the nutrition of the person, and so far the whole lifestyle of the person. It gives you guidance, saying kind of by red, watch it. There you have to be very careful.
And then, for example, like B12, people need intrinsic factor in order to utilize it. So there may be other factors that determine how. You can't a priori say this is the right amount
and
for this.
That's exactly what you say. That's actually functional genetics. Not only give blind something because the SNP is there, monitor it.
Right.
Very important. Monitor it.
And that's what's important about this whole test and genomic insights that we're doing is the resource we can use from the personalized intervention for the therapy.
Exactly.
And also having you as a resource too to help with interpretation, the results, and supplementation recommendations.
Exactly, because we only can give kind of like ideas, ranges, but the doctor or let's say the healthcare practitioner knows his patient and can act to that. We are giving recommendations. Yeah.
That's terrific. Well, I know there's a lot more detail to the story that you could elaborate on, but for now you've done a very good job of giving us the framework to basically understand it.
Thank you so much.
You're welcome. Thank you. Should we take? We had a number of questions that have come in.
Maybe we can just show also how this is not only the lab report, this is the first page, the other pages, just to give you an impression. We are doing also an interpretation, what is homozygous negatives, what is heterozygous, what you have to be aware of when kind of like here with MTHFR when you're taking antifolates. Antifolates are something like even when the MTHFR is good, you can't create 5,10-methylene tetrahydrofolate. So when the persons are antifolates, you have to use 5-methyl tetrahydrofolate.
This is very helpful information.
Very helpful information. For example, here at COMT, very important at COMT so far, or kind of we're giving you watch it, quercetin is also inhibit your COMT action. But what we also say here, when you are on, let's say, medication, or like we said before, entacapone and tolcapone and L-DOPA, be aware, kind of don't give SAMe because actually L-DOPA
will inhibit COMT.
No, COMT is not allowed to inhibit L-DOPA because it's on medication so far. So this are all these things what we are saying in order to and I had a case like that kind of like about 2 weeks ago, and I said kind of, I'm not your doctor, but I can tell you scientifically, don't use it. But please consult your physician. Please consult your physician.
And now physicians, can consult you if they.
Yeah, sure,
In
sure.
case-
Sure. But you see, these are all those hints, because this is actually kind of right now we are moving into this case of epigenetics, how
Right.
actually this can influence everything.
Right.
Right.
So far. And this is what we have to say in a lab report in order to make the physicians and the healthcare practitioners aware of it.
Yeah, the genes guide you, but it's not absolutely a cut in stone.
Yeah.
I mean, genes are different from stone. Stone is pretty immutable. Genes have a way of expressing, not expressing, and it's much more intricate
Yeah.
orchestration of processes. And so you have to
Yeah.
always apply clinical judgment
Oh yeah, sure.
to
Yeah.
therapy.
And here we are also at a whole discussion about hypomethylation and hypermethylation. I mean, sure there's hypermethylation, sure there's hypomethylation, but in kind of cases like that, where you're on L-DOPA, you have to consider things. You can't say, okay, now give SEMI-E, or when you're under hypomethylation, no, you're not allowed to give SEMI-E, and your COMT is not good. You see, it's always a question of the individual.
Who should have this test? What are the conditions that?
I would say everyone, kind of, because like we stated before, you saw the connection to all those cycles. I
Right.
mean, we are not talking.
Everybody benefits from
Yeah, sure.
from optimal gene
We are not only
expression.
talking about methylation, we are
Right.
talking about mitochondrial oxidative stress, or actually kind of like defeat the counteract for mitochondrial oxidative stress. We are talking about phase 2 detoxification,
Right.
conjugation with glutathione, which is one of the major phase 2 conjugation enzymes or pathways. I mean, it affects everything. Let's say it in this way: when you are young or when you're healthy, you don't feel it, but this can add up to chronic conditions later on.
Right.
So
Okay.
as sooner as you do that, is better. And again, a genetic test is only to be done once in your lifetime.
That's why you like to use the term lifestyle genetics.
Yeah, lifestyle genetics. I mean, lifestyle genetics. You see, this lifestyle
We're
genetics.
not diagnosing it. You're not diagnosing. And our lab is not diagnosing a disease.
No, we are not diagnosing a disease. We are actually, and this is a very good word what we had in Germany, kind of like making your aging, or when you're aging normal, kind of guarantee you a good lifestyle in old ages. Or what we say in Germany, kind of die healthy.
No, we say that in English too.
You're gonna die, but kind of like don't stay the last 5, 6, or 10
Right.
years in bed.
Well, the quality of your life. We're looking
exactly.
towards the improvement for that, and then really potentially identifying patients where they're having the issues, instead of throwing more pharmaceuticals at them. Maybe there's something you can do from a supplementation standpoint, or from a functional medicine, you could step in, address a genetic SNP that potentially maybe they just need more folic acid in their diet, versus going in and taking a higher medication to reduce their cholesterol or whatever the case may be.
Because also what you say, pharmaceuticals, I mean, we have this whole thing, pharmacogenomics. I mean, this is a huge thing, and people are taking drugs which according to their genetical picture can counteract.
Right.
And there's a number.
important,
There's a number about 40,000 about 40,000 people die in the United States yearly from drug abuse. Taking more. This is the
more like 200,000. That's what the reports are.
One of the leading causes of mortality.
But this is the official number.
Yeah.
There is a big number which is not known. Yeah, so far.
Well, yeah, it's true, unreported.
And,
you never really know.
The best example is Viagra. Viagra, kind of, when you have in your phase 1 detoxification CYP3A4, I think. When you have there a SNP, you take Viagra and you have a risk of heart attack.
Right.
Yeah. So people who are doing that should know
Jack
that.
Nicholson.
Yeah.
In the character he played in.
Oh, I was like, he's still
As
with
good
us.
as
What are you
it gets.
saying?
Sorry.
Sorry, you're listening, Jack Nicholson.
No,
we
no.
apologize for your early demise.
The character portrayed by Jack Nicholson in the Hollywood film, as good as it gets.
And I you see, I know a patient from Croatia, which I had. He had this problem.
Yeah.
He was about 68. And the doctor, every time I take Viagra, my head gets red.
The issue with when you're going for laughing gas for dentistry work as well. So let's see what else we have here, maybe on the slides, and then maybe we'll have time for some questions. I don't know how we're doing here.
Last but not least, we were showing you right now the interpretation.
Oh, this is good.
Here we're going to give you also recommendations. So we're going to give you recommendations of targeted supplementation so far.
This is important, So this is what a big part of the report, that we actually identify the supplements that the patient should be using based upon the genetic SNPs that are shown in their test.
And here you have again kind of like additional information where we are talking about also watch the glutathione pathway, vitamin B6, which is a cofactor in the glutathione pathway, L-cysteine, L-glycine, L-glutamic acids are recommended. Very important, these are the amino acids glutathione is made of. L-cysteine, you should be very much aware of that. And we're going to also have a test in the future for L-cysteine in the very near future. Too low L-cysteine levels are not good, too high are also not good so far, so you have to be careful about
Good. So we have sample reports if anybody would like. Just please contact us at the lab.
Here again, you have homocysteine in the serum, 11.63 so far, which is considered to be also in Europe. It's considered to be close to the borderline, very close to the borderline. Here in the States, we are using the recommendations of the National Heart Association. They say 15 to 30, but you see again, this is kind of like own interpretation. The doctor has to do his own interpretation. Okay.
Collection? Here is just basically, thank you for that. Just want to get into the ways you can send the specimens into the lab. We do now have buccal swabs that are available. If you all have to do is just go in and order those. We still have the sodium citrate tubes, which can be used for the genetic testing, and then if you would like the homocysteine test done as well, that will need to be collected in the gold top tube, which will need to be spun as per normal lab procedures. The genetic only test, though, if you could either do the blood in the blue top or in the swabs, and they're available again at no cost to any one of our accounts who request those. Dino, is there any preference as far as the two mediums, is it getting blood versus the swab?
Well, to my experience, and I've been doing that since 1998, buccal swabs, or let's say saliva, or cells from the mouth, are much, much better for DNA extraction, to my experience, but not only to my experience, also to experience of other labs. And what's very important, they are much more stable. Kind of when the saliva, or let's say the buccal swab is dry, then you immobilize all these enzymes which can degrade DNA.
Right. Okay.
So to my belief, or to my experience, and also to experience of my labs I had before in Germany, we switched to swabs in the year 2000 to swabs.
And it's non-invasive, so I mean it makes collection very easy. Unless you're already drawing blood for the patient, we have the swabs available for you. Okay?
Exactly.
Anything else?
Okay, collection jobs.
Okay, and then we just get into basically here's the profiles that we have that are already prearranged. We have the 5 genes in homocysteine in the advanced MethylDetox profile, and also we have the 3 genes in homocysteine in the basic MethylDetox profile. So the advanced and basic are basically just difference in 2 genes that are not in one versus the other. So 3 genes in homocysteine in the basic and 5 genes in the advanced. We do have individual gene testing available as well. So let's say if you've done MTHFR in the past and just want to go back in and test for COMT, AHCY, MTRR, we do have the individual genes which are available, and again, with or without homocysteine and homocysteine by itself. So any of the values that you do need to have that are relative to this test, and to find out the information that is relative to you as far as how your genes are functioning, we do have mostly the combinations that are covered that will be important to you as per our offerings with the lab. Okay?
Should we open up to some questions?
Yeah, let's see. I think
let's do that.
I think that's it for the slides. Yeah.
Okay, great. We have a number of questions from both before the show and during. We actually had a number of questions relating to homocysteine itself. One asking, what does it mean? What is the impact of high homocysteine? And also another question in the opposite direction of, what about homocysteine being too low? And what are the impacts of that?
Okay.
Yeah.
Good. Very easy. Let me go a little bit back, kind of taking this homocysteine, and I can explain it very, very easy. Where do we have it? Okay, homocysteine here. Homocysteine. When you have high homocysteine levels in the blood, you have here the sulfur group. And this sulfur group is highly reactive. So this is also highly reactive, for example, when you have a high oxidative stress in your system, in the blood. You know? And this actually converts then homocysteine or makes it, oxidizes it, so far makes it electrophilic. So, and what does it does then? The homocysteine actually creates plaques. Yeah. So far,
immunogenic, I think, as well.
Yeah, everything. I mean, it's homocysteine is then actually acting as a radical too. Yeah. So far, it creates plaques. So far, it attacks the system. So far, this is when you have high homocysteine levels.
Damages.
When you have low.
Arteries.
Oh yeah, but that's the reason kind of why you also should do chelation therapy with ADTA, mild chelation therapy to get rid of those plaques. That's also one cause, not only metals, but also, and I'm sorry, I'm not an expert, but this has been done in Germany a lot of time, kind of like also to get rid of the plaques. When the homocysteine is too low, you see here glutathione synthesis. It can also be that the glutathione synthesis is running high because too high, you have to detoxify. I mean, there are a lot of reasons, and you can find it out, for example, when you do a glutathione ratio. Yeah, glutathione ratio means oxidized glutathione to reduce glutathione. Then you see normally whether the body detoxifies, what we're also going to have in the future. Also, kind of we're working on that too. So you see everything, there are a lot of things what you don't have to, what we say in Germany, fish in dark waters, do a test. So you know what it is.
You get the information and address that by doing the test and finding out where to target.
Yes, exactly.
Very good.
Fish in Caribbean water.
Yeah, fish.
That's blue.
Okay, yeah.
Another question?
Absolutely. This is a bit of a follow-on question is, how often should one retest homocysteine?
Well, that's a very good question. I mean, first, we are a lab. No? We don't know the person, we don't know the patient. This doctor or the healthcare practitioner knows it better, but in the average, I would give a hint, let's say, in the order of 2 to 3 months. It can also be in the order of 2 to 3 weeks. It depends on the physician, on the healthcare practitioner. He knows the patient, but I would say at least after 2 months.
If someone comes with very high levels of homocysteine, you might want to monitor more frequently.
More frequently.
If they're more...
Makes sense.
You see how they're progressing.
Exactly.
Normalize.
Sounds good.
This is more of, I guess, a question specific to our laboratory is what kind of support is available to providers in the form of perhaps a post-test consultation?
Okay. Well, I think the great advantage we have is actually Dr. Saleta in-house, making an appointment for follow-up consultation on any of the test results, or even prior to testing if there's any questions, certainly available via email or call your representative to get in contact with Dr. Saleta so that we can go ahead and set up a consultation prior to testing or post results.
Yeah, sure.
We may have addressed this during the presentation, but I was asked again, is there a recommended age where it makes sense to begin to look for this?
Well, what we can say, I mean, your genes are never going to change as early as possible. You don't have to have a disease. I mean, you can also do it in prevention. And again, the genes, the SNPs are never going to change so far. Don't wait until it's too late, or what do you say in the States, so far.
Here's a question from just a moment ago is, are you familiar with any research that I guess discusses the differences in folic acid and other folates?
Oh, folic acid and other folates. Sure, there's a lot of research about that. I mean, I'm more than happy to answer this question, but this can take about an hour. There is a lot of research there. And this is also actually clearly organic chemistry. Folic acid and folates, but this person can call me up, then I can tell him really what it is. No?
Okay. Yeah, please email us or give us a call at the lab, and we'll go ahead and get that answer for you. It seems like it's going to be a little more in depth.
Sure, because there's a lot of misunderstanding between folic acid and folate. A lot of, and to tell the truth, it's a fault of the internet, which is providing a very much wrong information.
Thank you. How does the information from this test, the MethylDetox profile, help those utilizing chelation therapy?
Well, what we said right now before on the other question. When you have plaques created by homocysteine through oxidative stress, when homocysteine itself gets a so-called radical, so far, then what we recommended in Germany, I mean, I'm not a doctor, but I'm a scientist, but I worked with the German Chelation Association, Chelation Therapy Association. Yeah, they used that in order to get rid of, in order to treat those plaques. But so far, and this is kind of like the major thing what I can say.
So a buildup of these plugs, you're saying chelation therapy
to reduce those plugs,
to bring back to balance.
Because EDTA, what they're using in chelation is EDTA. And this EDTA kind of like gets a lot of also radicals, causes the radicals. We don't have to go into the biochemical structure of EDTA, but it's a very powerful chelation agent. Powerful but moderate. Doesn't do everything, but there's a lot of things through chelation, and the chelation therapists know it better, also according to mineral supplementation before and after chelation and all this blah blah blah. But
there's protocols.
Yeah,
and that's another.
Yeah. I mean,
so would this help somebody in terms of?
Oh yeah, sure.
Monitoring the. I mean, knowing about certain SNPs, is that going to impact?
Oh yeah, sure. It's going to impact. I mean, we did chelation therapy in Germany also with MTHFR and also some genes, but we also used for that glutathione S transferase genes too. And we developed in Germany protocols according to those SNPs. Yeah,
okay.
So far.
So there are protocols that have been developed. Are they using those protocols in the U.S.? Do you know if there's crosstalk between the?
I don't. Well, they're using it, to my knowledge, in Mexico, because we did a lot of seminars for University of Mexico. It's used, yeah.
And it's interesting to point out that chelation therapy has been sort of controversial for a number of years, but recently there's been an NIH-sponsored study that's been completed and shows that it works. So
it works.
There's still resistance to it, as there would be, but
I mean, it's not the answer to all the questions, but really it works. And normally what you have to see, or you have also to, when you do chelation therapy, you have to do challenging tests and blah 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 with DMPS, DMSO, and all this stuff. I mean, it's a very sophisticated treatment, and where it's much more involved into that than only giving ADTA.
Right. Sure, it has an effective application.
Sure. Sure, and that's the reason why you should go to a very good doctor who's doing that.
That's actually in general.
in general, in general.
We have another question pertaining to high homocysteine, and the question asks: Are there any physical attributes or signs that might reveal to a provider that high homocysteine is at play?
They mean like a physical presentation?
Some sort of indicator that would inspire one to look into it.
Well, after a certain while, you're going to get high blood pressure.
Yeah, you're going to have damage to the arteries and then build up a plaque and then higher blood pressure.
You see, but you shouldn't wait for that. I mean, just measure your homocysteine in your SNPs, and then you know for sure.
Yeah, it's easy enough to measure.
Yeah.
Could you, I guess, expand on the symptoms of overmethylation?
Overmethylation, we are here again at this question, overmethylation so far. Symptoms of overmethylation, what can symptoms of overmethylation be? Kind of that you shut off your whole genes, also the DNA repair enzymes. But when you do that, it's too late. Yeah. But the fact is
there much risk of overmethylation?
I mean, I speak open. Over-methylation is right now came into fashion. So far, like a couple of years ago, under-methylation. Sure, there can be a risk of over-methylation too, and that's the reason why we suggest also look into the methylation potential and look into the whole homocysteine cycle. You can have over-methylation, but it can be harmful. There are also scientific literature with over-methylation when you have Helicobacter pylori. Sure, it can be, but from taking normal dosages of SAMe-E, normal dosages, not like the person I told you before who came in with a whole basket.
Yeah, more is not necessarily better for any instance.
Yeah, normal dosages, yes,
back
because
to body balance.
SAMe-E is very, very much also involved or used by practitioners for neurological conditions, other than, for example, depression and all this stuff. When you use SAMe-E in moderate doses, actually nothing can happen, but still we can do the methylation potential. And
what about increased oxidative stress and reactive oxygen species? Something that would be something you would think would be a part of the other methylation that would be a concern. Is that
when you have over-methylation, you don't have actually anything in your body.
Yeah, okay.
The genes are shut off. Yeah, sure, sure, then you have oxidative stress, sure. Right. But you see, to reach that point is high. And under-methylation is also very important, because when you under-methylate, when you under-methylate, for example, then your oncogenes are not shut off.
Okay.
Yeah.
Well, and don't want your genes to shut off.
And this is the first step actually to aging. And we are also talking about cancer in aging. And
we introduced testing of telomere length.
Yeah.
And that's very complicated to
sure.
That would be a good thing to look at to see if there's that would be a good indicator.
Could be telomere length, could be, there are a lot of things which you can look upon. And again, what you say, when you are under-methylating, it's something what has to do with age. Because all your systems with age are going slower and slower due to mitochondrial oxidative stress and so forth.
Okay.
But I'm more than happy to answer this question on the phone too. I mean, we can discuss about that for hours. No?
As we pass the hour mark about 15 minutes ago, this will be the last question for this evening.
Oh, already.
And it asks, why choose the MethylDetox profile over other methylation-oriented tests?
What I would say is really just because of what we offer different than anything else that's in the market. And a lot of that is really just it's the interpretation of the results and supplementation recommendations we give. It's the value-added service that we have that isn't just throwing the results out to someone. It's really the incorporating that into helping the doctor's office, adding to a service versus making them take an extra step. This is actually basically an unpaid service we would provide. Additionally to giving the test results for these patients who have potential to have their therapy intervention with just a supplement versus having to go down a more dangerous road of going on a chronic pharmaceutical pathway of titrating up because they're not getting the results for a certain condition that needs to be addressed, that we could potentially intervene with just a supplementation recommendation. So I think that's what our leg up is and what we offer that's unique, a product that we have versus what else is out there. Certainly other products out there are good in what they do, and they certainly aren't to be disregarded in that sense, but we give extra value to what we have basically for the input that we have from Dr. Saleta, and then also doing the extra step and showing where you should intervene and how you should do it.
And we also have a strong group of people who are very dedicated. This is a number of people that are involved. They're behind the scenes, but we follow. We're a specialty lab, and so Cell Science Systems takes very seriously the importance of reporting out valid information and providing good customer service and the professional consultation.
Yeah, and we're empowering doctors' offices and other clinics with this information, so it's not so intimidating more than anything else.
But you see, yeah, that's what I want to add. I mean, you're free to do it everywhere, but what I think, and I did a lot of those things in the past. Right now, we are looking at the most important genes and most important SNPs right now. And yes, I mean, you get a clearer picture because in such accumulation, you're not going to get that somewhere else.
So that's been very interesting. There's a lot more to discuss. We'll be continuing with future webinars and future information.
More developments.
And developments as they come along.
Yeah.
So thanks to everyone for their participation.
Thank you.